Lesson 1-5 was over solving equations using square roots and cube roots. So the objective is to be able to solve equations involving square roots and cube roots. The first example was when you have equations that are involving perfect squares. So basically a number times itself gives you a perfect square. So Darius is restoring a square tabletop. He wants to finish the outside edges with a piece of decorative molding. What total length of molding will he need? So couple things that are important in this. We have a square tabletop. Okay, it's a two-dimensional thing here, so we're dealing with squared. You can also look at the unit, feet squared. That 2 there is going to tell you, are you doing a square root problem or a cube root problem. He wants to finish the outside edges with a decorative molding, so we're looking for what are these side lengths here. They're going to be the same since it's a square. And then finally, what is the total length of molding he will need? So that's asking for all 4 edges added together. So we're technically looking for our perimeter here. But in order to find the perimeter, we got to find the length of the side. So our area is going to be equal to our side squared, our side times side. So in this case, our area is 25. And we're looking for the side length. So what times itself is going to give us 25. So in order to solve for the side length, we want to take the square root of both sides. What this is going to do is it's going to cancel out the squared with the square root. These are opposite, so they cancel each other out. So now we're left with s is equal to the square root of 25. And that's one of your perfect squares that you're supposed to have memorized by now. So the square root of 25 is 5. Okay, so that means that this is 5 feet, this is 5 feet, all the sides are 5 feet. So if I want to find the total length of molding he needs, I'm going to take 5 feet plus 5 feet plus 5 feet plus 5 feet, or you could just do 4 times 5 because we have 4 sides and they're each 5 feet. So he is going to need 20 feet of molding. Okay. Example 2 is an equation involving a perfect cube. So this time we're dealing with a 3-dimensional figure. You can see the unit has the cubed. So Kyle has a large cube-shaped terrarium for his iguana. He wants to cover the opening with a square screen. What are the dimensions S for the screen? So we're looking for the 2 dimensions of this square. But in order to find that, we have to use this volume. Okay, so since it's cubed, we're going to be looking at volume, which is equal to the side length cubed. Our volume here is 343 feet cubed. In order to get rid of this cubed, I'm going to take the cube root of both sides. These are going to cancel each other out, and I'm going to end up with S is equal to the cube root of 343. The cube root of 343, if you're not sure, you can go through some numbers and multiply them. So let's just say 6 times 6, which is 36, times 6 again is 216. That's a little low, so you would try 7, and 7 is actually the cube root of 343 feet here. Okay, so that means that all of these dimensions here are 7. It's a 7 by 7 by 7. Now I want to know what are the dimensions for the screen. The dimensions are 7 feet. Okay? And that's all you got to do for that one. And finally, solving equations that involve imperfect squares and cubes. So these are ones that you cannot find the perfect square or the perfect cube. So it's going to be solved the same way. So in order to get rid of this 2, or to undo it, I'm going to take the square root of both sides, and that's going to leave me with an x isolated on my left side of my equation. What you do to one side, you have to do the other side of your equation. So I'm going to end up with the square root of 50. And since this is an equation and we have the ability to have positive and negative answers here, the answer for this one is going to be a positive and a negative square root of 50. Okay, since it's not dealing with dimensions or positive values, for example, in this first example, you can't have a negative 5 foot side of a wooden frame. You don't include the negative answer. For this one, since we don't really have a story that we're talking about, you're going to go ahead and include the positive and negative values. Okay, again, because a negative times a negative is going to give you a positive, just like a positive times a positive is going to give you a positive here. So our answer for this one is plus or minus the square root of 50. For our second example, we have x cubed equals 37. To undo this cubed here, we're going to take the cube root of both sides. When you have cubed, 37 is not a perfect cube, so I'm going to leave my answer as the cube root of 37. Now, with this one we had a positive and negative. With the cube roots, you do not. And the reason why is, and I'm going to give you an example of an actual perfect one, but let's say we are trying to find the cube root of 8, which you guys should know by now is 2. If I tried to do 2 times 2 times 2 is 8. If I tried to do negative 2 times negative 2 times negative 2, so if I used a negative answer, it's actually going to give me a negative 8, because a negative 2 times a negative 2 is a positive 4, and a positive 4 times a negative 2 is going to give me a negative 8. Now that doesn't work with this. So for cube roots, you can't have a negative answer. With square roots, on the other hand, you can. So if I'm doing the square root of 25, for example, okay, I know that 5 times 5 equals 25, and negative 5 times negative 5 also equals positive 25. So this is why we have a positive and a negative. So just something to be careful of when you're solving these problems. Whenever you have a square root, make sure you're including that positive and negative answer. For the cube roots, if it's a positive that you're taking the cube root of, it's going to be a positive answer. If it's a negative that you're taking the cube root of, it's going to be a negative. That's all I have for today, and thank you for watching.